Okay, welcome back to the wonderful world of logarithms. Um, this is the third video that I will be concluding the explanation of log rules in. So if you haven't watched the other two videos about log rules, you may want to do that depending on your level of familiarity and comfort with the topic. Those other two videos, one was the explanation of log rules with examples. There was about 6 log rules that were covered in that video. And then an additional video covered the change of base log rule. And in this video, I will be talking about the rule involving expansion and contraction of logs, or expanding and combining logs. This log rule oftentimes is called by two separate log rules in a lot of texts. One is called the product property of logs, or the quotient property of logs. What I like to do is combine it into one single log rule where we do the product and quotient all together. For example, in this particular formula, we have the log of multiple terms here combined as products or quotients. If we were to call it just the product rule, it would most likely be written like this, where they would show you how to simplify something that was just a product of two terms. The quotient rule would probably be shown like this, where it's shown as just the quotient of one term divided by another term. Again, I like to just kind of throw it all into the same log rule, so that no matter how many terms we have multiplied together or divided inside that argument, we can just think about that as one long string and cover it that way. I do believe that the best way to understand this log rule is just to do examples. So this first set of examples, I'll be focusing on expanding a log, which means you have a single log, and we're going to write it as the sum and or difference of multiple logs. Then we'll cover some examples of doing the reverse, where we actually have multiple logs written out as a sum or difference or both, and we're going to look at combining it or condensing it back into a single log. If you can do one, you can do the other, because they're just the reverse of each other. Okay, so I'm going to start simple and get a little bit more complicated as we go down. If you look at this log rule, the key is if you have a single log and if you have terms that are multiplied or divided by each other, we can split it into multiple logs. The key is to identify how many unique terms you have that are multiplied and or divided, and that would be the number of logs we're going to split it up into. So this particular formula, we have 1, 2, 3, 4 different terms, all multiplied or divided. So we're going to split that into 4 logs. The base, whatever that happens to be in this generic formula we just listed as a b, it's very important that you make sure you list that base when you split it up. A lot of students may forget to do that, and then you could get not full credit on a problem because you didn't list the base properly. The other key fact is each of these terms, once you split them up, they either will have a plus sign in front of them or a negative sign in front of them. And that's completely determined by the position of the term in the original argument. The terms that are on the top or in the numerator get plus signs. The terms that come from the bottom or the basement, the denominator, those get minus signs. So again, that's very important. You do not need to put a plus sign here at the beginning. I just did that for emphasis to indicate that that M had come from the top. Okay, so again, we're going to look at a couple of examples and try to learn the rule that way. So if I say I want to expand this into the sum and or difference of multiple logs, the first thing I would note is I seem to have 3 different terms inside of here. I have an x, a y, and a z. So because I have 3 unique variables all multiplied or divided by each other, I'm going to write this as 3 logs. So there's log number 1, log number 2, log number 3. Note that there isn't a base listed. That means it's 10, and so I don't need to list it. It's implied it's going to be a 10. Then I have an x, a y, and a z. So I'm going to list each of those. There's the x, there's the y, there's the z. And then the last thing is, do they get pluses or minuses? The x is on top, so it has a plus. You don't have to list it. It's implied unless you put a negative. So it's implied that that's positive. The y came from the top, so that will also be positive. And the z came from the bottom, so that's negative. And so we have separated this single log into the sum and or difference of multiple logs. So pretty straightforward. Now let's complicate it just a little. So this next problem, if you look at the number of terms you have that are multiplied and or divided, to me it looks like I see 4 terms. I see an x squared, I see a y to the 1/3, I see a 2, and I see a z. So because I see 4 unique things, I'm going to go ahead and break this up into 4 logs. So there's number 1, number 2, number 3, and number 4. Okay, now this happens to be a base 2, so I'm going to make sure that I fill in the base in each part. So get my 2's all put in place, and then finally I need to put these into the argument position. So here's x squared, here is y to the 1/3, a 2 goes right here, and then finally my z. Okay, now do they get pluses or minuses? The x squared and the y to the 1/3 were both up top, so they're both going to have plus signs. And the 2 and the z are both in the bottom, so they both get minus signs. Okay, so when you get to this point, you might think you're finished because we have expanded this as the sum or difference of multiple logs. However, it's generally not accepted to leave it this way. Anytime you have a log with an argument to a power, the best way to write that, and what is generally accepted, is to actually take that power, and using one of the previous log rules we've learned, you take those powers and you actually pull them down in front. So I need to do that. Anything that's not a 1 needs to be brought down. The z here, because that's a 1, which we don't write, you don't need to bring anything down. So I would rewrite this as 2 times the log of x to the base 2 plus 1/3 times the log of y to the base 2. And this is interesting. Maybe some of you have seen. If I left this as log of 2 base 2, I probably would not get full credit on a problem, because this is one of those previous log rules we talked about where the argument and the base match. So this, if you're paying close attention, is actually, there's my minus sign, and that is a 1. So the best way to write this is actually as -1. And then finally, this one can be left alone. There's no simplification to do to that one. So this would be minus the log of z base 2. So this is the best way to write that answer. So you can see I had 4 terms in the beginning. I have 4 separate logs. One of those logs, interestingly enough, because it was a number, I used a different log rule to simplify it. And then any of those arguments from the initial problem that have powers, the preferred method is to bring those powers down in front. So this would be the best answer for that problem. Okay, so last one for expanding. This one is fairly interesting. Number 1, it's the natural log. So as we get ready to break this apart, we'll make sure that we use the natural log in each of those expressions. This radical right here, that's what makes this very interesting. As long as all of these terms are in a radical, I can't really do anything to that. I can't really break it apart yet. So what I would like to do is we're going to rewrite this using an algebra process where you can take a radical and rewrite it as a fractional exponent. And so let's just rewrite this quickly like this. The natural log of, I still have x squared minus 4 divided by e cubed times w to the 5th. But let's take this radical and write it as a fractional exponent, right, like that. Okay, so now that we have that accomplished, we're going to be able to use another log rule that if you have the log of an entire argument to a power, we can actually take that power and write it down in front. So let's do that next. So I'm actually going to write this as 1/2 times the log of x squared minus 4 divided by e cubed w to the 5th. Okay, so now this is really ready for me to break it apart. This 1/2 is just going to be a multiplier that sits out front when I break this log actually apart. And if you look inside of here, there's really only 3 terms. Because this is x squared minus 4, that negative sign means this is one term, okay? So I can't break that apart the way it's written. Some of you may have noticed that this is difference of squares. I could factor it and write it as a product of x plus 2 times x minus 2, and then it would be 2 separate terms and I could break it apart, and we'll take care of that piece in a minute. Let's just get this broken into 3 logs at the moment. Actually, let's scratch that. Let's go ahead and write it as the product. Either way is fine. We'll go ahead and do it this way. So let's rewrite this. This is x plus 2 times x minus 2 if I use my factoring skills. And this is e cubed times w to the 5th. Okay, so by factoring it first, I can see that this is actually the product and quotient of 4 separate terms. X plus 2 and x minus 2, now that they're written as a product, those are both up top and I can split those apart. And then the e cubed and the w to the 5th, those are both down in the bottom. So I really have 4 terms here. So if I rewrite this, I have my 1/2 as my multiplier out front. And then I'm going to put some big brackets here. And now I'm going to separate these into 4 different logs. So I have, and they're natural logs, I have 1 natural log, 2 natural log, 3, and finally 4. And then I'll close that bracket. So let's get ready to place these in each of these 4 positions. So this first one is x plus 2. The second one is x minus 2. This third one is e cubed. And this fourth one is w to the 5th. Okay, now plus or minus signs. These 2 were both up top, so they both get pluses, so that's implied. Put my plus. These 2 were both from the basement. They both need negative signs. And so at this point, if you think you're done, not quite, so this one is a little bit more challenging. You gotta always ask yourself, am I quite done? And if you remember from the problem above, if you have an argument with an exponent, we really want to take those and move them down front. So that's what I'm going to do here. This 3 will actually come down right here as a 3. And this 5 will come down here as a 5. Okay, so now if you think you're finished, not so fast, there's one final thing that we need to do, and that is, if you look at this term right here, you may notice that this is now 3 times the natural log of e, but what is the natural log of e? There was that other rule that said that base is really there even though we don't write it, so we have the situation where the argument and the base match, so this would simplify to a 1, so you really have 3 times 1. So let's go ahead and write that out. So the final answer, I have 1/2 times the natural log of x plus 2 plus the natural log of x minus 2. This became a minus 3, and this was minus 5 times the natural log of w. Okay, and then if you wanted to, you could take this 1/2 and distribute it through, but it's not necessary. So we started out with a fairly simple example and kind of got a little bit more complicated as we moved down. That is how you expand logarithms. Okay, so now let's look at doing the opposite. What if we actually were given a problem that was already expanded as the sum or difference of multiple logs, and we actually want to combine it as a single log? The key here is to realize we're going to do everything in reverse order. So again, if you can expand, you can combine. You're just doing all the steps in reverse. So again, I started out with a more simple example, and we'll try to get a little bit more complicated as we go down. Okay, so this first example, I am going to first make sure that the bases match, because we should never be combining logs together into a single log if the bases don't match. And you can see, you know, the goal is not to try to trick you. They should all be that way. So these are both 2's, so I can combine them. In this problem, they're all natural logs, I can combine them. These are both log base 10, I can combine them. And these are all base 3. So again, it's good to get in the habit to check that and not assume, but when they ask you to combine or condense, they should match, because they're wanting you to go through the process of being able to do that. Okay, so let's combine this first one. So first of all, if I want to write this as a single log, I get ready to write it as a single log, okay? The question is what is going to go inside the argument of that log? If you scan quickly, because I have a plus sign and a minus sign, I know I have a term that's going to go up top and down below, so I can get ready to do that. The M had a plus sign in front of it, so that M goes up top. The Q had a minus sign in front of it, so the Q goes down below. And then don't forget it was base 2, so let's make sure we get that base written in. So that one is fairly simple. The next one is a little bit more complicated, and what makes that the case is you are not allowed to take multiple logs and combine them into a single log unless you make sure that any coefficient that happens to be written in front of that log needs to be a plus or a minus 1. And when you get down here, you can see that's not the case. This has a 1/2 as a multiplier, this has a 3, this has a 4. That's not okay. And if you remember on the previous one, when we were separating, one of the final steps we did was if we had powers up top, we brought them down below. So again, if we're going to be doing this combining, kind of thinking about reverse order, if that was one of the last things we did to separate, then it should be one of the first things we do if we combine. And so anytime you're going to do a combining, if you notice that there's a number out here that's not a plus or minus 1, that really should be your first step, is to go ahead and pop those up. So that's what we're going to do. We're going to take this 1/2, and it's going to pop up as an exponent on the x. We're going to take the 3 and pop it up as an exponent on the y, and then we're going to take the 4 and pop it up as an exponent on the z. Notice I didn't do anything with the negative sign. The negative sign stays there. That's going to indicate that this term is going to end up going to the bottom when we get ready to combine. So let's go ahead and we can rewrite this. So that's going to be the natural log of x to the 1/2 plus the natural log of y cubed minus the natural log of z to the 4th. Okay, so now that I have plus or minus 1s in front of each of these, now I can go ahead and combine it. So we're going to get ready to write it as a single log. I do have pluses and minuses. That means I know I am going to have a numerator and a denominator inside that argument, so I'm going to go ahead and get ready for that. This is actually natural log, so you'll notice I wrote a log here. So I'm going to go ahead and put the log base e, which you really should write that as a natural log. Okay, I'll take care of that in the next step, okay? If we combine these, the x to the 1/2 and the y cubed, they both have pluses, and so they're going to go in top. And the z to the 4th, that has a minus, so it's going to go down to the bottom. Okay, so let's get ready to do that. So I have x to the 1/2, y cubed, and z to the 4th goes down below. And note that when I put them into the argument, they're all multiplied or divided. You're not adding or subtracting anything. So you literally take each of these things and you just write them directly as a product or as a division. Again, the positive terms get put up top, negative terms get put down below. So this is where you might think that you're done. However, again, common notation, let me make sure I write that as a natural log, which I could have done back here. I just wasn't paying attention. Sorry about that. So we're going to write it as a natural log. And then as I get ready to write what's inside there, whenever you have a fractional exponent, which is what this 1/2 is, when we combine back, the preferred way to write a fractional exponent is actually as a radical. And so don't be surprised if you see that, if you see your instructors doing that, if you see the book doing that. You could occasionally see it left this way, but it's not common. Again, it's preferred to write it as a radical. So x to the 1/2, that's actually the same as the square root of x. And so that's how I'm going to write that piece. This is still y cubed, and this is z to the 4th. So this is the best answer for how I would want to conclude that problem. Okay, moving right along. This one's interesting. There's only 2 terms here, but what's interesting about this example is they're both negative. And sometimes if all the terms are negative, it poses the question of what do you put into the numerator of the argument of the combined log. And so first let's make sure that we're taking care of getting these multipliers popped up. So we're going to do that first. Okay, so what we really have here then is minus the log of w to the 5th, and then minus the log of q, and that's going to be to the 1/3, okay? But I'm going to go ahead, and since I'm going to have a fractional power there, q to the 1/3, I'm going to go ahead and write it as its radical form now, which is going to be the cube root. You don't have to do that at this step. I'm just going to go ahead and take care of that, okay? So now, how do I combine this into a single log? Well, let's get ready to do that. I'm going to write log. I have terms that need to go in the denominator of the argument because these are negative. So I'm going to get ready to write a numerator and a denominator. But this is kind of the trick here, is what goes in the numerator because there's no positive terms. Well, when there's no positive terms, we actually have to put a 1 up there as a placeholder, okay? And then now I can put this w to the 5th down below and this cube root of q down below. And if you're wondering if this is correct, imagine what would happen if I were to break this log back apart. Well, you can see that this piece would result in these 2 terms, right? This term, because it's up top, it would actually result in me adding a positive log of 1 right here. But what's the log of 1? The log of 1 is actually 0. And so that's why this is mathematically sound to go do that. And so just a little interesting note if you haven't seen a problem like that. Okay, last example. This one, we have a multiplier out front. And so if you wanted to, you could push this 2 in, you could distribute it into each of those terms, and then take that 2 individually and pop it up. I don't think that's necessary at this point. Instead, I'm just going to kind of leave this guy out here as a multiplier and focus on how would I combine this problem, okay? So right now, each of these individual logs, none of them have numbers out here outside of plus or minus 1, so I don't need to pop anything up at this point. But let's go ahead and combine this then. So I still have my 2 as a multiplier out here. I'm going to write this as a single log. It happens to be base 3, so I'm going to need to make sure I put that in there. And then I do have, this is a positive term, and these 2 are negative, so I am going to have something up top and something down below, okay? And so this x, with the being a positive term, it's going to be up top. This x plus 1 has a negative, so it's going to go down below, and I'm going to protect that with parentheses, okay? And then this x minus 1 also goes down below. Okay, now what's the best way to leave this? Well, again, remember, when we're combining, we don't like to see these multipliers out front. So now I can go ahead and take this 2 and pop it up top of that whole thing. So this is what that's going to look like. I have log of 3, base 3, and then I actually have my x. I'm going to rewrite this as x plus 1 times x minus 1, and then this multiplier is going to pop up outside of this entire argument, which is why I want to make sure I put this whole thing in parentheses. Now, one final thing, you may see some individuals leave it this way, but I happen to notice that this is something that could probably be foiled back together pretty cleanly. So it's okay to go ahead and do that as well. And we could pretty cleanly write this as x, and then if I FOIL this back together, it's x squared minus 1. So a good thing for you to practice would be, if you really understand both processes, taking an expansion and combining it, or doing something combined and expanding it, is with all of these examples, now you know what both forms look like, so can you go back and forth? And so if you really understand both, you should be able to take this expansion and see if you can combine it back, and you could do that for each of these problems. And then likewise here, if you had been given this at the beginning, could you have broken it apart? Again, I would argue that if you can do one, you can do the other. So that is it. That is the final log rule in a series. I hope this has been helpful. If you think it has been, something you could do, a suggestion could be that you could subscribe to this YouTube channel. If you subscribe and you hit the bell, then you will continue to be notified as I post more videos, which there will be more videos coming very soon. You can also tell your classmates about it. So if you think this is a resource that is helping you as you are working to transition into your online learning, I would like as many people as possible to be able to take advantage of this resource. So again, hopefully you find it helpful. If you do have any questions or suggestions, you can feel free to put those in the comment section below. I'd be happy to take anyone's feedback about things that you think are helpful or not, and make modifications as necessary. So I hope this helps you out, and look for some additional videos. I'll be still compiling videos on graphing. How do you graph exponentials? How do you graph logarithms? And then how do you solve equations using exponentials and logarithms? And then finally, remember, we're culminating to be able to solve real world problems. And so those will be the final videos that I get posted in the series of exponentials and logs, are some real world applications. Again, hope this was helpful, and don't hesitate to provide some questions or suggestions if you have them. Thank you very much.